Every QA engineer talks about test plans. Most of them have never written a good one. And the ones that have been asked to write one on the job have usually produced something that gets reviewed once, gets a few comments, and then sits in a shared drive folder and is never opened again. That is not a test plan. That is a document that exists to say a test plan exists. A real test plan is a strategic document that answers a specific question. Given everything we know about this project right now, how are we going to verify that it works? Who is responsible for each area? What risks are we accepting? And how will we know when we are done? A well-written test plan is what separates a QA engineer who executes from a QA engineer who thinks. It is what you bring to the kickoff meeting that makes the engineering lead and the product manager look at each other and realize they have someone on the team who is thinking about this systematically. In this episode, we are writing a complete, professional test plan from scratch. We will cover every section, what to put in it, what to leave out, and crucially, how to make it actually useful to the people who need to read it instead of the kind of document that gets written once and never opened again. The first and most fundamental section of your test plan is the scope. This is where you define in writing exactly what you are testing and, equally important, what you are not testing. Both parts of that definition are critical. Both require explicit decision-making. For a typical web application sprint cycle, in-scope might look like this: user registration with email and password, login and logout flows, product search and filtering, cart management including add, remove, and quantity changes, and the checkout flow on Chrome and Firefox desktop browsers. Out of scope for the same sprint might be mobile browser compatibility, admin panel features, third-party payment processing which is handled by the vendor, performance under concurrent load which will be addressed in a separate performance testing phase, and accessibility compliance which is tracked separately in its own workstream. Writing the out-of-scope section is not about avoiding work. It forces three critical conversations that need to happen before testing begins. What are we not responsible for in this cycle? Who is responsible for it? And has everyone agreed on that boundary, specifically the product manager, the engineering lead, and any stakeholders? A test plan with no out-of-scope section is a test plan waiting for an argument. Usually the argument happens at the worst possible time, right before a deadline, about whose bug something is and who should have been testing it. The second section is your test strategy, and this is where you move from scope to methodology. The strategy answers the question: given what we have decided to test, what types of testing are we going to do, in what order, using what tools, and why did we make those choices? A complete strategy section for a typical sprint might read like this. We will perform functional testing on all in-scope features against the documented acceptance criteria. We will perform regression testing across the full feature set at the end of each sprint to ensure that new changes have not broken existing behavior. We will perform API-level testing on all new backend endpoints using PyTest and the requests library, running before the UI tests as a faster, lower-cost verification layer. And we will run exploratory testing sessions on each new feature within 48 hours of it landing in the staging environment, with a timebox charter approach focused on edge cases and user flows not covered by the formal test cases. Notice that the strategy also says what we are not doing and implies that those areas are either handled by other teams or are explicitly accepted as risk for this cycle. That level of clarity is what makes a test plan a decision-making document that earns respect, not just a paperwork exercise that satisfies a process requirement. The third section covers entry criteria and exit criteria, and most test plans either skip these entirely or write them so vaguely that they are useless. Entry criteria are the specific conditions that must be true before testing can begin on a given feature or release. They protect the testing team from spending time in a broken environment or testing against an incomplete build. Concrete entry criteria for a feature might include: the build deploys successfully to the test environment with no application startup errors. All critical and high-severity bugs from the previous testing cycle are resolved or have accepted workarounds. Test data is seeded and confirmed accessible. API documentation is updated to reflect the new endpoints. And the feature has passed a developer smoke test. Exit criteria are the conditions that must be true before testing is considered complete and the feature is cleared for release. They might include: all planned test cases have been executed at least once. No open critical or high-severity defects remain without an accepted resolution. Test coverage for the in-scope features meets the agreed threshold. And the regression suite passes with a failure rate below the agreed tolerance. Without exit criteria, testing never officially ends. It just stops when someone with authority decides to ship. With exit criteria, that decision has a documented standard attached to it, and if the team chooses to ship without meeting the criteria, that choice is visible and deliberate, not accidental. Entry criteria and exit criteria exist to create shared agreement before a testing cycle begins and before it ends. Without entry criteria, you risk burning testing time on a broken environment, an incomplete build, or missing test data. Without exit criteria, you risk shipping code without a clear, documented, agreed upon definition of done. Both of these failure modes are common, both are expensive, and both are entirely preventable by writing 4 to 6 bullet points at the start of the project. The fourth section is your risk register, and this is where test planning becomes genuinely strategic. A risk register lists every known risk that could affect the quality of the release and documents the likelihood, the potential impact, and the mitigation plan for each one. Common risks in software testing include an unstable or frequently reset staging environment that causes tests to fail for environment reasons rather than code defects. Test data that gets modified or reset by other teams without notice, causing test preconditions to fail unexpectedly. Requirements that are unclear or still evolving for specific features, making it difficult to write test cases with confidence. Third-party integrations like payment gateways or email providers being unavailable in the test environment. And tight sprint timelines that compress the available testing window if development runs late. For each risk, you document 3 things: the probability that it materializes, the impact if it does, and what the team will do to either prevent it or respond to it. A risk register is not pessimism. It is professionalism. When a risk that you explicitly documented actually materializes, you have already told everyone it was possible, you have documented what the agreed response is, and you are positioned to respond quickly instead of scrambling. When an undocumented risk materializes, it looks like you were not prepared. The test plan protects you as much as it protects the project. Risk registers are uncomfortable to write because nobody wants to be the person saying what might go wrong. But writing down what could go wrong is not the same as predicting failure or being negative about the project. It is the professional act of being honest about uncertainty. Every project has known unknowns. The risk register makes those known unknowns visible and gives the team a shared language to talk about them before they become incidents. Before I let you go, I want to leave you with the most important thing to understand about test plans. A test plan is a living document, not a one-time deliverable. You write version 1 before testing begins with the best information you have at that moment. Then you update it as requirements change, as new risks emerge and old ones resolve, as scope shifts because of business decisions, and as the testing strategy adapts to what you learned during the cycle. The goal is not a perfect document written up front. The goal is a document that at any given moment accurately reflects the current reality of the project. Include a revision history section at the top with the date, the version, and a brief note about what changed. This way, anyone reading the document knows exactly how recent each decision is. A test plan from 3 sprints ago that was never updated is not just useless. It is actively harmful, because it will tell people the wrong thing with the confidence of an official document. Keep it current, keep it honest, and keep it short enough that people will actually read it. In the next episode, we are moving from planning to execution. We are going to test a real REST API end-to-end using PyTest and the requests library, building a complete API test suite from scratch. Subscribe and I will see you there.